check 1 2. Looks like we're good. Double check double check 1 2 1 2. Okay, we're good. Just gonna turn this down a bit. All right. I'm gonna wait a couple of minutes until we get some people in. Let me share this out as well. All right. Nobody yet. I'm just waiting another couple of minutes and sharing this out still. All right, we're gonna get right into it. Let's get it started. Here we go. Welcome in, welcome in, welcome back. Episode 6 of Learning Web3, Web3Webs. I'm Expo Hiti. I'm a musician, artist, farmer, Web2 and Web3 developer. I do a whole lot of different stuff. So here today, like the other past days that I've come through, I've been providing this as a free resource for you to learn about Web3 and all the different things within Web3 without having to pay, all this kinds of money, having to sign up and do all kinds of stuff. It's all here available for you, free, and you can even join me in these live streams to get your questions answered, have discussions about this stuff, so you can really get a full, in-depth understanding of what Web3 is, because I've even been going back and forth in conversations with people on like the Blue Sky app and other places too. It just seems like there's this real huge confusion about what Web3 and NFTs and smart contracts and all this stuff truly is, because people get this inflated idea about it, right? And it comes from, and I mentioned this before, but it comes from the meme coin buzz, right? All of the people who are jumping into crypto just because they're hearing about, oh, you could potentially make all this money by trading meme coins and this and that, right? The Dogecoin and the cats and all the, all the different, right? All that stuff. And the NFTs as well. They do the same thing with that. But that's not the true essence of what Web3 is. That is not what NFTs were made for. They're not made for people to just sell to each other these pictures of cartoon animals. It's literally meant to be a more secure way to transfer and store data, and as well as finance, right? Store value. So to understand that, and to help people learn about this, I provided this resource because it also connects you to other things that can help you dive further into the specific areas of Web3 that you might be interested, because Web3 can actually expand and go into, and already is, getting into just about every aspect of our lives, right? Even companies like Amazon are using their own private blockchain to run their networks. And it's because it is the most secure option at the moment. There are other options available. There's ledger technology, there's, different things, right? But this is one of the best, especially for certain cases. And it's not for everyone, right? Not every company, not every industry, not every person needs to use a blockchain for their specific things that they want to do. But for those who find that they need immutability, confirmation of data, secure data over multiple networks that can't be erased from one central location, all kinds of different things that this provides, which we get into, right? You are going to want to use a blockchain, and it's not, again, just for the potential financial gains that people are speculating on. So we're still in presentation 2. For those of you who are new, this is Web3Webs. You can go and find this by going to Web3Webs.page, and it's right there for you. You don't need to sign up. You don't need to add in a credit card. You don't need to do any of that stuff. Just go to the website, and it'll be right there for you. Scroll down, and you can choose, which one you want to look at. I would recommend starting, obviously, at step 1 and going, each one up, because each one progresses into the next one. And this one I'm actually still finishing and working on. So make sure you get through the first 4 presentations before, I finish up that last one as well. Now, we already went through the first one, so if you missed that, go back to the previous episodes. We're on episode 6 now, so we've already gone through all of the first one and some of the second one, and we're going to continue on now with the second one. So just go ahead, you click right there. It pulls up the presentation, and it's right there for you. So hit present. Now, we left off on the middle module, which is what is a blockchain. So we'll continue on there. And for any time, right, if you're watching the stream and you have a question or a comment, or you want me to emphasize something or explain something more, let me know. Drop it in the comments. I'll go ahead and read that. I can see everything on my screen here, and I will help you out. Okay. What is a blockchain? Blockchain is a main component of Web3 that acts as a publicly verifiable distributed ledger. A network of computers all verify transactions continuously in a chain where each block in the chain is composed of 3 parts. The data from the previous block is the first part. The second part is a timestamp of when the current transaction was done. And third is the data from the current transaction, the wallet addresses, the fees paid, right? All the different data that is involved in the transaction. So it's a block because it has all of that stuff contained within it, and sometimes multiple transactions within one block, most of the time actually. And that gets into block size and all this other stuff. But right, we're doing overviews here. We're learning basic concepts, and then we'll dive more into it as we go on, and if you have questions. But I also did find this video here. It's a really good video. What is a blockchain? Provided by Simply Learn. I did not make this video, so I don't own the rights to anything like that. Shout out to them for making it. And there's other videos and stuff like this in here as well. So let me go ahead and turn off the music here, and then you can hear the video. Again, this is from Simply Learn. You can see they've got other stuff as well too you can check out, but this one is about blockchain, and it's one of the best explanations that I found.
Ever wonder if there's an easier way to complete transactions without having to deal with online wallets, banks, and third-party applications? Well, it's possible thanks to blockchain. Here's everything you need to know about blockchain. Imagine 4 friends, Jack, Ted, Sam, and Phil, meet up for dinner. After they're done, Jack pays the bill, and all of them decide to split the expense amongst each other. Now, on the next day, when Phil sends his share to Jack via online money transfer, the transaction goes through without a hitch. Then, Ted and Sam send their respective shares to Jack, but their transactions don't go through. The failed transaction cites some issues at the bank. That's when Jack comes to know about the many ways a bank transaction could fail. It could be due to technical issues at the bank, one of their accounts were hacked, daily transfer limits being exceeded, and sometimes additional charges, like transfer charges, associated with transferring money. To solve these problems, the concept of cryptocurrency came into existence. Cryptocurrencies are a form of digital or virtual currency that run on a technology known as blockchain. Thanks to blockchain, cryptocurrencies are immune to counterfeiting, don't require a central authority, and are protected by strong and complex encryption algorithms. And in a market of more than thousands of cryptocurrencies like Litecoin, Ethereum, Zcash, and so on, one reigns supreme: Bitcoin. Now, let's go back to our previous example and have Phil, Ted, and Sam send Jack 2 Bitcoins each as their contribution to the previous night's dinner. Let's assume Phil, Ted, and Sam have 3 Bitcoins in reserve, while Jack has 5. First, Phil sends 2 Bitcoins to Jack. A record is created in the form of a block. The transaction details between them is permanently inscribed in this block. This record also holds the number of Bitcoins each of the friends own. So, after Phil's transaction, Jack has 7 Bitcoins, while Phil has 1. Following this, Sam and Ted send 2 Bitcoins to Jack. A new block is created for each of these transactions. These blocks hold the transaction details as well as how many Bitcoins Sam, Ted, and Jack have in reserve. These blocks are linked to each other, as each of them takes reference from the previous one for the number of Bitcoins each friend owns. This chain of records, or blocks, is called a ledger, and this ledger is shared among all the friends, which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Phil has only 1 Bitcoin left, and he tries to send 2 more Bitcoins to Jack? The transaction will not go through. This is because all his friends have copies of the ledger, and it's clear that Phil has only 1 Bitcoin left. His friends will flag this transaction as invalid. A hacker will not be able to alter the data in the blockchain because each user has a copy of the ledger. The data within the blocks are encrypted by complex algorithms. All of this is made possible with the help of blockchain technology. Blockchain can be described as a collection of records linked with each other, strongly resistant to alteration, and protected using cryptography. Now, let's have a closer look at the Bitcoin transaction between Jack and Phil and find out how it works. Every user in the Bitcoin network has 2 keys, a public key and a private key. The public key is an address that everyone in the network knows of, like an email address of a user. The private key is a unique address that only the user has knowledge of, something like a password. First, Phil passes the number of Bitcoins he wants to send to Jack, along with his and Jack's unique wallet address through a hashing algorithm. All of this is part of the transaction details. These details are encrypted using encryption algorithms and using Phil's unique private key. This is done to digitally sign the transaction and to indicate that the transactions came from Phil. This output is now transmitted across the world using Jack's public key. With this, the message or transaction can be decrypted only by Jack's private key, which only Jack has knowledge of. Different cryptocurrencies use different hashing algorithms. While Bitcoin uses the SHA-256 algorithm, Ethereum, which is also a famous cryptocurrency, uses one known as Ethash. This transaction and several other similar ones are taking place all around the world. These transactions are validated and then added block by block. The people who validate these blocks are called miners. For a block to be validated and added to a blockchain, miners need to solve a complex mathematical problem. The miner who solves this first adds the block to the blockchain and is rewarded with 12.5 bitcoins.
Some crypto.
The process of solving the complex mathematical problem is called...
And it's not unique to Bitcoin. There's other blockchains as well. It's not just this. And there's different what's called consensus mechanisms, which we'll get into as well later.
Proof of work. And the process of adding a block to the blockchain is called mining. With this, Phil and Jack's wallets are updated, just like every person in the network who has completed a transaction. Now that you know about blockchain and its important concepts, time for a small quiz. What is the concept of blockchain that ensures data cannot be altered by any of the users within the network? A. Public distributed ledger. B. Proof of work. C. Proof of stake. D. Hash encryption. Let us know what you think is the right answer in the comments below. 3.
All right, go ahead and comment, and then we'll see who gets it right. But we'll keep on moving. So that's a really great explanation of blockchain and how it works. Shout out to Simply Learn. But yeah, let's keep on moving forward. We're going to move into now the consensus mechanisms I was just talking about, right? So one of the most popular consensus mechanisms, actually the one that Bitcoin uses, is proof of work. We had, like, Ethereum used to be proof of work, and there is now still what's called a fork of Ethereum that is still a proof of work Ethereum. But now the main Ethereum, the one that is actually being run by the Ethereum Foundation and everything, is actually now proof of stake. So it's a different one, and we'll get into that in a sec. So proof of work. Proof of work was the first blockchain consensus method that became popular through Bitcoin, like I just mentioned, and is generally the most secure consensus method. In a proof of work blockchain, computers are required to compete to solve complex transactional equations as quickly as possible, and the fastest computer to solve the equation gets rewarded with something, in this case, Bitcoin. These computers are called miners. And validators too sometimes, but we'll get into that. A major issue that has come up as the proof of work blockchain expanded is that it requires large amounts of energy and computing power to run, which can be extremely wasteful and damaging to the planet if done using non-renewable energy forms of energy. Even with clean energy sources, proof of work is not often a viable long-term solution for an expanding blockchain because as it expands, right, as you need to include more and more and there's more transactions running, proof of work actually is a bit too slow. It doesn't have enough TPS or transactions per second that it would be required to keep things running actually as needed. So there's become other consensus methods to speed things up. Then we've got new how blockchain works with this little diagram here. Just a nice little visual to help further help you understand it more, because I know some people are very visual, some people are auditory, so like the video helps. But yeah, so a transaction is requested, right? Then a block that represents the transaction is created. The block that is sent to every node in the network, because remember, it's a whole network of computers, of phones and all the different servers that are holding this data, that are running it. Excuse me. So it's being sent to every single one on the network. All the nodes, the nodes validate the transactions, the validators, The nodes receive a reward for the proof of work. The block is added to the existing blockchain, and then the transaction is complete. So that's adding each transactions, or usually it's multiple transactions in one block, and then they block them to link them together through a chain, right? Conceptually, it's not literally. There's not an actual physical chain linking these blocks together, right? it's conceptually. It's metaphorical. But okay, let's keep on moving forward. How can I get? There we go. I was trying to get out of there. Proof of stake is the one I was talking about. So proof of stake is a newer way for a blockchain to be managed, where people provide liquidity to be locked for the blockchain to run, while the people who have provided liquidity, or validators, right, we just talked about that, get paid staking rewards, just like they would in decentralized finance protocols. Proof of stake is proving to be a better alternative to proof of work because of the lack of need for numerous warehouses full of computers to be running to run the blockchain. On the other hand, there could be some issues with expansion in proof of stake blockchain if validators pull their liquidity and no more and no more new validators join the network, which is something to worry about, right? And that's why we need decentralization. So in the case of Ethereum, which a lot of people are probably going to be upset about me saying, Ethereum is highly centralized. There is a large majority of validators and nodes that are being held by just the company, as well as their investors, their large investors, JP Morgan Chase and the other ones, et cetera, right? A large number of these nodes and validators are one entity. So with all of that centralization, these people could just pull their liquidity. They could unstake, right, their Ethereum, pull it from the blockchain, and then now there's almost nobody there, almost no liquidity to actually validate transactions. So that is a very big issue. However, if the blockchain is good enough and actually can pull in enough of a crowd, right, so enough people who are going to use it continuously and distribute the ownership of the node and the network utility, right, between a large amount of people, so that it's not just a few people who own a majority, then we actually have a lot more better functioning things like this, and it can be more prolonging. It can last out into the future without worrying, oh man, is this actually going to fall? Because that's the whole basis behind blockchain, right? If one part of the network falls, the rest of it is able to hold it up, so that not just having it in one central authority. So now once that central authority falls, that's it. Everyone's data is gone, and that's it, right? But with these, it's everywhere. It's across the entire network. So the purpose is when one falls, it's in the rest. So having centralized, nodes and validators like that kind of defeats the purpose. Now, there's many other blockchain consensus methods that exist and are not covered in this course, but I actually do plan on making some more like specialized courses that focus specifically on certain topics, and they go really far in depth. But I'm going to have to wait until I have more help to do that, because I'm doing so many different things. So for now, you guys got the Web3Webs, which is just a basic overview, and then I have some links and stuff in there for more information that you can look out to. But like here we have this, the different consensus method chart. It actually has not all, but the majority of the different consensus methods that exist for these algorithms. And we're not going to really get into it too much, but just kind of show you around. We have proof of weight, right? Similar to proof of stake, but difference is that it depends on various other factors called weights. We've got proof of work, you already know. Proof of stake, you already know. We talked about it. Proof of delegated proof of stake, same as POS, right? Proof of stake, but users with more coins will get to vote and elect witnesses, and there's a whole process with that. Least proof of stake, users will be able to make customized tokens and use it on their farms for better security. Proof of elapsed time, similar to proof of work, but different in that it focuses more on consumption. Right, so if you are renting something, right, this is where that would come into play. So that at the end of the rental period, whatever it is goes back to the original database. Practical Byzantine fault tolerance, PBFT. Byzantine used as a particular sequence to keep the rogue users at bay. I don't really know too much about that, to be honest. I'll have to get into that more. Another one, simplified one of that version, delegated version of that, directed as acyclic graphs, DAG, which is actually a pretty significant one. Constellation, which is I'm pretty sure government-owned company, actually has the DAG blockchain, which is being used by the military. Yes, that's right, the U.S. military. And you can actually buy their coin. DAG is the ticker, DAG, because it's using directed acyclic graph technology for that purpose. It's not just for the military, but that's one of the users. Then we've got proof of activity. Uses both POS and POW to ensure the reward points are on time. So making sure, like, if people are actually doing, performing certain tasks, engagement tasks and stuff like that. Then we've got proof of importance. Users that frequently send and receive transactions will get paid. Proof of capacity. Using the protocol, you can utilize the capacity or storage space of a hard drive, and that's actually one that's become pretty popular too. And then proof of burn. Sorry, I just got a comment from somebody on social media, but yeah, so that's all the different consensus methods that they have. You can look more into them yourself if you're interested, but we've also got layers, right? So there's different layers to the blockchains. Most of the ones that you're familiar with are going to be layer ones, right? The big names, Bitcoin and all that. So layer 1 refers to the base layer of a blockchain where the blocks are recorded and acts as a foundation, but is often very limited in its capabilities. Example, Bitcoin, Ethereum, Phantom, Terra Luna, Avalanche, Tron, and there's a lot of others, but those are the pretty most popular ones. Then layer 2s, which are actually, it's kind of solving that issue that I talked about with scalability as well as speed, transactions per second, because we do have, like, Solana is a layer 1 blockchain which boasts having high TPS, but they have issues with their blockchain constantly shutting down, so and having congestion, right, where transactions are getting congested on the network. So while they do have some decent speeds, it's nothing compared, honestly, to some of the layer 2 solutions out there. So layer 2 refers to the extra layer built over the layer 1. This is often done to reduce workload on the blockchain, which reduces fees and also allows for more expansion, such as decentralized applications or dApps. And yeah, so, like, examples would be Polygon, Lightning, Lightning is for Bitcoin, Polygon is for Ethereum, Loopring, Arbitrum, Optimism, those are also, for Ethereum based. But these run way faster and way cheaper, right? So you're going to run a transaction on Polygon, and it's going to cost you a couple cents versus, in comparative to US dollar, a couple cents versus like $50 to use Ethereum, or even $20 to use Bitcoin, right? To use their blockchains. So it's almost insanely different. It doesn't even make sense to me. I mean, I understand, because, the whole elitist mindset, right? Oh, you got to use expensive stuff so other people can't access it, blah, blah, blah. But for those who don't care about that kind of stuff, why are people still so focused on using Ethereum and minting on there when they're paying so much? It doesn't make sense to me. You can mint on these other blockchains. Like, Polygon is still on Ethereum, right? Polygon, yes, has its own thing. It's a layer 2, right? It has its own separate system, but they're validating on the Ethereum network, right? They're taking their ledger, their transactions, and they're taking it over to put it on the Ethereum blockchain as validation. It just makes sense, It just makes sense. And then you got forks. So forks, not like what you're eating with, right? Forking a blockchain involves using the source code from an already existing project and changing it slightly, or upgrading it. And that's what we talked about too with Ethereum, right? Remember I talked about how Ethereum used to be proof of work, now it's proof of stake. That's because they actually had a fork. So there's two types of forks. A soft fork does not involve making an entirely new blockchain, but rather an update to the current one that is compatible as the blockchain moves forward. Example, BIP, which are the Bitcoin improvement protocols, right? 34, 65, and 66 were all soft fork upgrades of the Bitcoin blockchain. Hard forks involves making a completely brand new blockchain that is based on the original but is incompatible with the previous blocks because its code has a new set of rules that do not agree. Example, Litecoin, right? Litecoin is an actual hard fork of Bitcoin because it uses slightly similar coding, actually a copy of it that has been changed to meet the needs that the Litecoin team wanted. And a lot of that has to do with cheaper transactions, which they did accomplish. And Litecoin is very popular because of it. It actually doesn't get a lot of attention, but it's like a lot of press. It doesn't get like a lot of promotive attention, but there's a lot of people using it. So another example would be the Ethereum upgrade I mentioned. So oracles is the next one we're talking about. And remember, again, if you have any questions at all, feel free to stop me. Yeah. Oracles. I'm actually going to stop here in a couple minutes too. We're heading towards the end of this. So actually, since we're almost at the end of this, I should mention, remember that the sponsor of this live stream is my nonprofit organization I'm working on getting registered right now, the RMU Foundation. And you can check out more information about that at rmu.foundation. We've got a lot of stuff that I'm trying to put together there. I have different projects that I'm building and looking to partner with others to help me succeed, so we can work together to improve the world using technology. I have the Digital Food Project, providing food and supplies for people experiencing homelessness. I've got, obviously, Web3Webs, which you're watching right now, and other things in the works that are on the way. So go ahead and check everything out there. Even reach out if you are interested in helping out with anything like that. And let's get back to it. All right. All right, so third-party service providers that allow blockchains to pull data that is not on the blockchain itself. This is very important because smart contracts often rely on outside data to complete their functions, and oracles provide that data. Oracles themselves can also be centralized or decentralized and can be categorized differently based on the type of source of data they're pulling. There are some decentralized oracle projects already in the Web3 space that have gained popularity, such as Chainlink, Band Protocol, Eternity, and DOS Network. Chainlink is the number one popular one. Actually, in some of the contracts that I've written, I have used Chainlink oracles. Chainlink oracles basically, it's dealing with things like tracking time, tracking, different data measures from outside world sources. So everything can be kept up with in the smart contract itself, because smart contracts don't have access to like the news and like live data, right? It's not an AI. It's just lines of code. So by implementing these oracles, you can you can put into your smart contracts to actually interact with these live oracles that are processing live data and pull information so that your smart contract can act however it needs to based off of what you're doing. Sometimes, like for video games or for whatever it may be, you'll need to depend on outside source information for whatever interactions are happening within it. So that's where, in this case, you'll need oracles to pull from. And I know we're getting really technical here, but this is what we're doing. Like I said, if you got questions, drop them below. Okay, I think we're going to be able to finish with this one here, because Merkle trees is a whole concept of its own. So we're going to just finish up with roll-ups, and then we'll close up the live stream for today and come back tomorrow. What's today, actually? Yeah, so tomorrow's Friday. All right, roll-ups. A roll-up acts as a secondary consensus layer to process transactions faster and then have them confirmed by the main blockchain. There's two main ways for roll-ups to reach consensus with the main chain. ZK rollups, ZK or zero knowledge rollups use mathematical proofs using computers to verify the data and are generally more scalable than optimistic. Examples that use ZK rollups are loop ring, immutable X, and Polygon. Great ones to look into, by the way, not financial advice. They have coins. And optimistic rollups assumes by default that all transactions are valid and rely on users reporting possibly fraudulent or incorrect transactions. Examples that use optimistic rollups are Arbitrum Optimism, which is the most popular in my opinion, and Boba Network. Now, these rollups are basically helping to do. Remember how I talked about that second layer, right? These layer 2 blockchains that they have their own ledger system, their own system that they're then validating on the main network. Well, this is how they're doing that, how they're validating. They have these roll-up methods, right? They roll up all the transaction data and package it and send it to the main blockchain for validation. So there's different ways of doing that because you want to make sure that all the data you're sending to the blockchain is valid because it's going to be permanent. It's going to be on the main blockchain that cannot be changed, right? So you have to be 100% sure that the transaction data you're sending is valid. So ZK rollups, in my opinion, are probably the strongest. And I think there's another type that came out recently that's showing a little bit more promise. I forgot the name of it. I got to look into it more and do more research. Remember, Web3 is a constantly evolving and growing. This is the edge of technology here. So I'm going to have to constantly learn and add stuff too, right? We're learning together here. So now ZK rollups, in my opinion, right now are the strongest because I get it. Optimistic rollups are faster. It gets things done quicker, but there has already been a lot of issues with these optimistic rollups having invalid transactions in their databases because, like it says, it assumes by default that the transactions are valid. It just assumes everything is valid, and if nobody reports anything, it just goes through, right? So that runs into a lot of issues. People can be malicious and actually do false transactions and all kinds of stuff. So that in itself has already caused issues, proving to me that ZK rollups are a little bit better of a solution. And that's a huge reason why I use Polygon over Optimism or Arbitrum. So yeah, that's just, a little bit from me. But that's the end of it for today. Thank you for joining me. Again, I'm Expo I'm a musician, artist, farmer, Web2, Web3 developer. So if you actually need anything, right, if you need a website, a metaverse space, some music, I don't know, something, right? If you need any of that kind of stuff, artwork, 2D or 3D, hit me up. You can find me on all platforms at Expo or go to expohiti.com and you can check out all the stuff there. Obviously, if you want to check out the presentations and go through the rest of it yourself, you can. So you can go to Web3Webs.page like you've seen scrolling over here at the top the whole time. Go ahead and check it out there and go through everything yourself too and come back with some questions so we can have a chat. All right, so I'm going to be doing another video in a second here. I actually was doing a live reaction to the new episode of Futurama because they have the whole episode pretty much is a little bit about NFTs, and it's pretty interesting. They have a lot of accuracies, but I was like, I don't know, right? So I'm doing a live reaction, going through and commenting on it, and so I already did the first part, but YouTube got me on a copyright strike because I kept on playing it for too long. I got to make sure I keep pausing it and talking so that I don't get that this time. But we're gonna do the part 2 now in about 15 minutes here. So. Signing off now. We'll see you next time. Tomorrow, 3 p.m. Central Time, right around that time. I don't get it exactly at 3 p.m., right? So just be on the lookout, and I'll see you tomorrow. All right. Peace.